Hello everyone. Welcome to the fifth interaction session for the Control Systems course by Professor Shankar Ram. I hope I am audible clearly. So this is the fifth week, and you might already know I am Soumya. I am a PMRF fellow at IIT Gandhinagar, and I am your TA for the course. So we have been here for 4 weeks, and we have learned a couple of things. So last week, if you remember, we were going through second order systems. We came to know about underdamped, overdamped, critically damped or no damped system, and how do we identify what are they and what are the location of the poles that make the system to behave in a certain way for damping, right? Then we learned about some of the controllers. So mostly it was P, I, and the combination of all of them. So it was basically going till the end to PID controller. And then after that, we also looked into closed loop control, right? So uh, finding out the closed loop transfer function. We had a couple of questions on performance specifications as well. You came to know that there are many performance specifications for second order system given a step response. So it is defined by it can be rise time, it can be peak time, it can be maximum peak overshoot, settling time, all of these, right? So we have done many questions on that. Today also we'll have some questions on them. But what we covered last time was something called Hurwitz polynomial, right? And to satisfy being a Hurwitz polynomial for till to a second order system, it was so easy that we could certainly find out the roots, say that the roots are in the left half of the S-plane and the system is stable, right? It was pretty easy. For first and second order system, it can be very easily defined that this is the fixed condition in which the roots are going to lie in the left half of the S-plane. What if we go for higher orders? Right. So necessary condition is that for stability, the polynomial should be a Hurwitz polynomial, but there is also a sufficient condition which comes from Routh's array. So in short, to define stability for any characteristic equation which is of more than second order, we need a proper, necessary and sufficient condition which is given by screen is not visible. I have shared the screen. Uh,
No, not visible, ma'am.
Not visible. Okay.
Slide is visible.
Slide is visible now. Slide
No,
only is
visible
visible.
first slide.
Yeah. I haven't changed the
No.
slide till now. That's right.
Okay.
Shabita, is the slide visible to you? The thing that I am presenting? It could be a problem with your network connection. I don't know. Okay, if there is further problem, please let me know. So yeah, all of these things we are doing, right. Today we have some questions on Routh-Hurwitz criteria. I hope you have already gone through the fifth week lectures by Professor Shankaram, and there he has very well explained how do we construct Routh's array, why do we construct it, and moreover, what are the special cases in Routh-Hurwitz criteria, right? Apart from this, we'll also see some of the performance specifications. How do we find out? How do we go about that? How do we find the gains of a controller for maintaining the system stability? So all of those things we'll be seeing today. Okay. So let's move forward. Just a brief recap of what was told in the lecture. So this is one of the slides from his lecture from which we had already done. Just to revise, that we had started with second order system, right? And then we wrote the generalized form of second order system. We wrote the transfer function, right? ys upon us is omega n square upon s square plus 2 zeta omega ns plus omega n square. After writing this in this form, with a damping ratio and natural frequency, what we found out that there are two poles of the system from the characteristic equation. So it can be it is minus zeta omega n plus minus omega n under root zeta square minus 1. So we usually represent it in this form, and then we saw under damped system in which there are two conjugate poles and both of them lie in the left half of the S plane because the real part of the pole is negative, so it lies in the left half of the S plane. So let's say if there is a hint in one of the questions that both the poles lie on the left half of the S plane and they are conjugate pairs, you have to take the hint from there that it is an example of underdamped system, right? If there is a case in which it is said that there are poles in conjugate pairs and they do not lie in the left half of the S plane, they are just cos and sine terms are there, and there is just, for example, plus 2j minus 2j, then you have to say that yeah, it is not damped, it is an example of undamped system. Similarly, for overdamped and critically damped, there are conditions which you must, so all of them, so the nature of poles, actually whatever has been taught to you is of great importance. You'll be able to answer directly from here that what is the nature of the system given the placement of poles, right? And this is important. So yeah, from here I just wanted to just make a note of one thing, that you can see that the real half of the pole is minus zeta omega n, right? Do you remember what is the formula of settling time? So if I say for 2% criteria,
Zeta by 4 omega n.
are you sure? Zeta by 4 omega n or 4 by zeta
4,
omega n?
4 by zeta omega n.
Right, right. So it is 4 by zeta omega n. So this pole, just if we
No,
ignore the
it's for 2% criteria. No?
right, right, it's for 2% criteria, and for 5% criteria is 3 by zeta omega n. Okay, so let's say
In
talk about.
question, will they give we should use 2% criteria or 5% criteria? No?
I did not get your question.
In question, will they give we should use 2% criteria or 5%
See,
criteria?
if they give 2% or 5%, answer accordingly. If they don't give, mostly they don't give, okay, and they just ask you for settling time, then in that case you have to go for 2% criteria. Is the rule.
Okay.
Because 2% criteria is the better one. Settling time, if you're going within 2% of the steady state value, that means you have very less error at the end and your response is even more settled. 5% is somewhat before that. That is why we answer for 2% always. Okay. So from here you can see, yeah, the real part is minus zeta omega n, right? So this zeta omega n comes in settling time as well. That means the real part of the pole, whatever it is, has a direct impact on settling time, right? The farther or closer you are from the imaginary axis, how your poles are located is going to have an impact on the settling time. So this was something to just look upon. We'll have questions also on this, but yeah, this is one of the things that you have to keep in mind. Okay, let's start with what we are going to do today. So I hope you have already gone through lectures, and this slide I had in the last class also, where I was just introducing Hurwitz. So Hurwitz is if all the roots have negative real parts. That is just the definition of Hurwitz. Now, for having all the poles in the negative real parts, we came to know that there are two conditions. One of them is all the coefficients should be non-zero, and the second thing is they should be of the same sign, either positive or negative. It's not a problem because at the end we have equal to 0 only. So if it is positive, then also it is 0. If it is negative, then also reversing signs would eventually like absorb the sign in 0. So this we know that this thing stands for second and first order system. So it is very easy. to say that just for having the poles in the left half of the S-plane, what we need is all the poles should have the characteristic equation should have the coefficients to be non-zero, and all the coefficients should be of the same sign. That's it, right? Let's move to third order system, because problem starts from here. So till here for first and second order system, satisfying these two conditions actually make the polynomial Hurwitz, which means that roots have negative real parts and they lie in the left half of the S-plane, making the system stable, right? So these two conditions are just sufficient till second order system. What goes wrong with third order system? So there are two examples that are covered. One of them was this D1, right? If you try to, so you get many solvers online as well. If you try to find out the roots of this characteristic equation, what you will see, all of the roots are lying in the left half of the S-plane. Now, let's go by these two conditions. Are all the coefficients non-zero? Yes, all of them are non-zero because we have coefficients for each power of s. The second condition is, are all the coefficients of the same sign? Yes, all of them are of the same sign. This is also satisfied. Both the conditions are satisfied, and if you want to take a look at these conditions, you would say that yes, the system is stable as all the roots would lie in the left half of the S-plane, right? And if you find out also using a calculator or by finding one root, substituting it and getting a quadratic equation and solving for the other roots, you will also find that all of the roots actually lie in the left half of the S-plane. But could there be another scenario? Yes. There was another example taken, which was D2. And if you try to find the root of this polynomial in solver or on your own, you'll see that one of the roots lies in the left half of the S-plane and two are in right half of the S-plane, which says that the system is unstable, because any pole in the right half of the S-plane is a problem. It makes the system unstable. But do you get any hint from here that the system is unstable? No, right? Because all the coefficients are non-zero and all of them are positive. So from here you don't get any hint of instability. That means these two conditions help us. They are both necessary and sufficient condition for first and second order system, but they are not complete set of conditions for n greater than equal to 3. So something else has to also come into picture. Okay. So what we do for order 3 and above, there is a necessary condition that comes in, and that necessary condition is, necessary condition is already there, which was for Hurwitz, that all the coefficients should be positive, non-zero and of the same sign. So if you find that this is a problem, if all the coefficients are not non-zero and not of the same sign, you can directly reject in the first sentence that it does not satisfy the necessary condition and the system is unstable. But if this condition is satisfied for a polynomial, it has to go through a second check. That second check is the sufficient condition, and for that we construct Routh's array. Now, this Routh's array construction is really simple. What you're supposed to do, you're supposed to arrange the coefficients only here, and then you're supposed to do cross multiplication. For remembering, this cross multiplication is opposite to that of what we do for determinant. Okay? So in determinant, what you do? You do a0 into a3 minus a1 into a2. Right? In this case, it is opposite. First you do the other diagonal. It's not the principal diagonal. Okay? So it is a1 into a2 minus a0 upon a3, and you divide by the first row term in the second row always. So it becomes a1. Becomes a1, and for b1 you have a1 into a2 minus a0 into a3 divided by a1. Okay? For finding out b2, you have to take the first row and that row for which you are trying to do the multiplication. For that you get b2 here. Okay? So you have B1 here, B2 here. Similarly, you proceed forward, divide by B1, you get C1, divide by B1, you get C2. Like this you always get, right? So the number of sign changes in the first column should be 0. So when we are constructing this array, and this array is constructed until you get a single number at the end, okay, and no further multiplications and divisions are possible, it just ends there, okay. So what happens if you have to just, after constructing the Routh array, you just have to look at the first column, and if there are no sign changes between consecutive rows in the first column, you will say the system is stable. The number of sign changes you have, एक बार positive था, it became negative, then again it became positive, that means two roots lie in the right half of the S plane. So the number of sign changes you have say that those number of poles actually lie in the right half of the S plane and the system is unstable. Alright. So we'll have many examples also for this. So in this case you can see Routh's array is constructed over here. So how do you do? The higher order polynomial is written over here, matlab s cube, s square, s1, s to the power 0. Now what you will do, in the first two rows you will fill all the coefficients that you have. They are filled in such a order that 1, 2, 3, 1, this is our thing, right? 1 is here, 2 is below that, 3 is in the second row, and 1 is in the second row. This always goes on, matlab alternate positions happen. Okay. Now when you try to find out the value for S1 in the row for S1, you will just multiply 2 into 3 minus 1 by 2. So here you get 5 by 2, right? Yeah. And after that you do for this next row also, you will multiply, and you will see that you will get this value only, 1 only. Okay. So if there are, so you can see here 1, 2, 5 by 2 and 1. Since there are no sign changes, so all the roots have negative real parts and the system is stable. In this example taken, there are 2 sign changes and the system is unstable, right? So all in all, what you have to understand for Routh stability criterion is just this, that if you are given a transfer function ns upon ds, then the system would be VBO stable if all the coefficients of ds are non-zero and are of the same sign, which is the necessary condition. Which is the necessary condition, and the column of the Routh's array constructed using the coefficients of all entries being non-zero and are of the same sign. They all should be non-zero and should be of the same sign. Now, if it comes to be 0, that is another special case, and that has also been dealt in the lecture, right? What happens if one of the the entry in the first column is 0, and the other case is what happens if entire row is 0. So in one of the cases we replace it by epsilon and then try to proceed forward, assuming epsilon is a very small positive number. In the other case, when the complete row is 0, what do? We try to find out the auxiliary equation and see that okay, there are radially opposite roots and the roots, and then you try to find out the stability of the system by finding out the auxiliary polynomial by differentiating and all those things you do, right? So after this, okay, I'll not go through everything, but this is also one of the examples that you might have seen. Here there is a 0 coming over here and it is replaced by epsilon, and then you do with the epsilon, and then there, and what do you find? So replace the 0 entry with a small positive number epsilon and continue the process, right? After this, if there is a sign change from the entry above epsilon is assumed to be positive, alright? If there is a sign change, then there are roots in the right half of the S plane. If not, there is a pair of roots on the j omega axis. That is all you have to infer from here, alright? We'll have questions on this as well. So if there are 2 sign changes, then 2 roots are there in the RHPI. Okay, it is pretty simple. Then there was another case discussed which I haven't taken here. I hope you have already seen the lecture for the complete row becoming zero and how radially opposite roots are present. The next thing I wanted to move was what I covered in the first slide. So dominant dynamics of closed loop control system behave like that of underdamped second order system with settling time of almost 4 seconds and a maximum peak overshoot of it now. Okay, leave that. What is important is we are not solving any question here, but this thing is important. That settling time is 4 upon zeta omega n, and this zeta omega n. So if I say your settling time should be less than 4 seconds, that is what is done here. Okay, your settling time should be less than 4 seconds. Then where would you place the poles, or where would you place the real part of the pole? Okay, so from here you can see zeta omega n is greater than equal to 1 and minus zeta omega n is less than equal to minus 1. So you know that I have to anyway place the real part of my pole for the underdamped system, second order system, to be less than minus 1. That is the information you get from here, given I have given you some settling time. So if I gave you some performance specification, my maximum peak overshoot should be this percent. My settling time should be this number of seconds. My rise time should be this number of seconds. You should be able to design a system based on them. Yes, there are trade-offs and there are conflicts, but the question would not definitely ask you everything altogether. But there can be questions which uses a mix up of all of these, and then you have to find out, okay, where I should place the poles, what value of zeta I should choose, what should be natural frequency of the system, all of those. All right. So yeah, this is important. Recall that the real part of the poles of an underdamped second order system is minus zeta omega n. All right. Now, this is also one of the things that we covered in one of the lectures. I think I already did a derivation for this, but still I am taking you through this, and after this we'll directly solve the questions. So you remember that a closed loop transfer function is for a system is given by gs upon 1 plus gshs, right? And this is the normal block diagram of a system, of a closed loop system, right? Where you have GS to be plant, HS to be sensor, YS to be output, and then WS is the output signal which is being taken as feedback from the sensor. ES is the error which is derived from the difference between the reference and the what is the output that is being sensed, right? To give a real-time feedback. This we already know. So we just have to manipulate this equation to find out some relation between reference value and error. Okay, so what we do is ys can be written as, from here how you can write ys, it can be written as es into gs, right? This is ys upon rs is gs upon 1 plus gshs. I am copying essentially the same equation. I am just replacing ys by es into gs. Cancel out gs. So what do you get? You get error upon reference is equal to 1 upon gshs, right? So from there you can write es is rs upon 1 by plus gshs. Now, if I ask you steady state error, what is steady state error? Steady state error is as time tends to infinity, what is the value of my error? If you apply the final value theorem, you can directly write it as limit s tends to 0 ses, right? And you can substitute the value yes over there, which is rs upon 1 plus gshs, right? We have used this already and we'll keep on using. For example, it is not always so easy to go back into time domain and do the analysis, because if you have already come from time domain to frequency domain to just ease the problem, and then to solve the differential equations in algebraic form, you get some algebraic manipulations of the equation. So when you try to take the inverse Laplace, sometimes it becomes really tedious process if they are not a direct inverse Laplace of what we have studied, right? It can be something different, or maybe you might not remember at the moment, it might not strike you. So if it does not, this final this final value theorem comes to your rescue. Okay, it's really simple. You just have to substitute the value of s to be 0 in SES. Okay, there is another thing which is also defined. Let's say my GSHS, which is open loop transfer function, is given by some equation. Then there is a way in which we define the type of the system. I don't think I've taken any example. Okay, yeah, but we have a question coming up. So what happens here is, so let's say it is represented by this general form. You manipulate it in such a way that there is no the last term does not have any coefficient of s. Any s that is common in the transfer function in numerator and denominator should come out. The last term should be a constant. Okay, 1 is a very general representation, but even if it is constant, it's not a problem. You just have to pull out all the extra s out of it. For example, if there was if the polynomial was until here only, then 1s could have been taken out as common, right? But since we have a constant over here, we cannot take out any s common. So whatever s you have, if you take it out, and whatever power remains by solving the numerator and denominator for power of s, that becomes the type for system. It's type 0 or type 1 or type 2. Now what do we do with type 0, type 1, type 2, and why do we define that? Comes when we want to find out what is the error. So we'll have an error analysis also. It would mostly come in the next week. Let me check. Yes, we have steady state error analysis coming up in the next week. So that comes after defining the type of the system, and we come to know that, okay, what would be the error given. This is the type of the system and this is the kind of input provided, and then you get a table of 3 cross 3, which is like easy to remember as well. You can always solve it on the spot and you get the answer, but it is good if you remember it. Okay, so yeah, this defines the type of the system, and we'll close our lecture here at type of system only today. Okay, so this is the first question. So if all the, just a second. Yes. Okay. If all the roots of the polynomial lie in the left half of the complex plane, then that polynomial is called what? We just covered it. Can anyone answer?
Routh-Hurwitz polynomial.
Right. It's called a Hurwitz polynomial. And a whole story today is going to be based on this only, all the questions and everything.
Then why it's not Routh polynomial?
It's not called Routh, right? Because we studied in the definition here. Where did this go? Yeah. Okay. A polynomial is said to be Hurwitz if all its roots have negative real parts. Okay. Routh, see, you have to prove that a polynomial is Hurwitz, that all of the roots have negative real parts, right? Now, for doing this, for first and second order system, it was really easy because it provided us with the necessary and sufficient condition. But for third order and forward, it did not provide us the necessary and sufficient condition. We did not get this necessary and sufficient condition from these two ways of checking. Then there we constructed Routh's array to prove that the polynomial is Hurwitz. Okay?
So there is no such thing called Routh polynomial.
No, there is nothing called Routh's array. That is it. This is just Routh's array.
Okay.
And the whole name of this criterion, which is used to find if the system is stable, is called Routh-Hurwitz criterion. So there is no Routh's polynomial, it's just Hurwitz polynomial, which we want for stability, and that is determined from sufficient and necessary conditions. Sufficient condition comes from those first two conditions, that they should have the same sign and all the coefficients should be non-zero, and this what do we say, the necessary condition comes from Routh's array. Oh, they don't exist. There would be Bode plot coming in. I think after 2-3 lectures it will come into picture. Nyquist plot will also come in. We are going to have questions on all of them in the coming lecture. So all of them are plots, and they are methods of finding out the stability of the system in frequency domain, not in time domain. So what we are actually Rouse is also this frequency domain analysis only. For time domain, you will directly find out if at t tends to infinity, what is the situation, right, for y. And in frequency domain, you are going to construct some plots which would be coming as a part of Bode plot and Nyquist plot. In a time domain analysis, we will have one more thing coming up for stability, which is called root locus. So we'll be studying this also. Okay, let's move to the next question. The polynomial s square plus k minus 5s plus 8 minus k, where k is a real valued parameter, has all its roots in the left half of the s plane for all. Now, can you answer this question? Here so I'll give you. Here should we just okay. So all of you have appeared for JE Advanced, right? So I'll give questions accordingly. All coefficients are non-zero. All coefficients are of the same sign. Routh's array construction. Okay. Can you tell me, for solving this question particularly, what is the bare minimum number of things that we want for this, or do we need everything?
First two condition needed.
Yeah.
Second condition.
First as well. First two conditions would be sufficient to answer for this question. Third condition is something which we do not need, but we can definitely test it over here. What happens? So let's say if there is a polynomial of second order, see, first and second order, for these two, these conditions are directly sufficient. You don't need to check this condition. But if you go and check this condition, then also you'll get the same answer that the system is stable, unstable based on what you were getting for the first two conditions. It is going to remain the same. Okay. But as soon as you move to n is equal to 3, you have to look at all these three conditions. Okay. So in our case, it is a second order polynomial. So we just have to look at the first two conditions because they are necessary and sufficient both. For n greater than equal to 3, they are not necessary, they are just sufficient. That is why we construct Routh's array. Okay, let's see. S square plus k minus 5s plus 8 minus k is equal to 0. This is my equation. All the coefficients should be non-zero. That means k cannot be equal to 5, definitely, and k cannot also be equal to 8, right? After this, all coefficients should be of the same sign. Now this s square has coefficient to be 1, which is positive. That means that for the other powers of s also, we need the coefficients to be positive. So k minus 5 should be greater than 0, which directly says k should be greater than 5. From here you get 8 minus k to be greater than 0. That means 8 is greater than k, which means k is less than 8. So k should be greater than 5, k should be greater than 8. Okay, it should be in the range of 5 to 8. K belongs to 5 to 8. So from here, what is your answer? Your answer is D. I hope it is clear. Okay, if there are no doubts, let's move forward. Okay. So the polynomial s cube plus 4s square plus s plus 6. Where do the roots lie for this equation? Do all of them lie in the left half of the S planes? Few in left, few in right. How many in left, how many in right? That we need to see. Alright. So let's construct Routh's array, because here n is greater than or equal to 3. So the very first thing is we have to check the first two conditions. Both of them are satisfied, right? We don't have any missing powers of S over here. That means all of them are non-zero. The second thing is all of them already have the same sign. That means a sufficient condition is satisfied and we need to look for the necessary condition. Sorry, am I confusing between these two? I think necessary condition is satisfied, which was having both those things, and for sufficiency we need to go for the other ones. Okay, let's construct the Routh's array. So let's write s cube, s square, s to the power 1, s to the power 0. How do you arrange it? 1, 4, 1, 6. Right? Can someone tell me what would be the fillings in the other rows? It is very simple, right? If I say here is some a1, here is a2, here is a3. How would you find a1? A1 would be 4 into 1, which is basically this cross multiplication, minus 6 into 1 upon 4, right? So it's going to be 4 minus 6 minus 2 by 4, which is going to be minus 0.5. So we can replace it directly by minus 0.5. Right? We don't have anything over here. Have I done correctly?
Yes, ma'am.
Okay. Okay.
Next one is going to be 6.
It has to be 0 and it's going to be 6. Okay. So the rule is you have to reach till the end by putting zeros where you don't get the values, because here we don't have anything, so here it came to be 0. So from here we are able to construct the Routh array, and by seeing this we can say that there are two sign changes, right? When you come from here to here and when you come from here to here. So there are two sign changes, and this is so 2 roots in RHP and 1 root in LHP. How did we say 2 and 1? Because in total it has to be 3, and since there are two sign changes, so 2 of them lie in the right half of the S plane and 1 root lies in the left half of the S plane. Alright, that is why this is the correct option. I hope this is clear. Okay, let's move to the next question. The polynomial s cube plus 4s square plus 6s plus 1 has how many? Let's construct the array again. S cube s square s to the power 1 s to the power 0 1 4 6 1. Okay. From here what you get? It would be 24 minus 1, 23 by 4. Right. It would be 0 and here it would be 1. So again there are no sign changes in the first row. No sign changes. That means all of the roots of this equation lie in the left half of the S plane. So this is the correct option. Is that clear? Any confusion? Okay, let's move to the next question. This is really simple. It's just doing practice for Routh's array. Okay, let's go about this. Again we have to check. So I'll s cube s square s to the power 1 s to the power 0 1 4 2 8. It's going to be 0. It's going to be 0. Now what? We have to find out how many poles are lying where. Let's replace the first term by epsilon. Now let's check what happens. It would be 8 epsilon minus 0 upon epsilon, which turns out to be 8. That means, and this epsilon was some positive real number. Okay, so if you have a look at the first row, you will see that there is no sign change, and from here we can say all 3 roots lie in the left half of the S plane. Right?
Ma'am, is it not a zero row, ma'am?
Sorry?
Is it not a zero row, ma'am?
You can count it as 0
And is
row
appearing
also.
in.
It can be solved in both the ways. From there also, when you solve, you get the same answer. And when you do this now, what inference we can get from here is,
Because here finally we need to apply a limit that epsilon tends to 0.
right. Yeah, epsilon doesn't tend to 0. It is just a very small positive real number.
After
That's all.
finding the equation at the end, we need to substitute epsilon tends to 0. Then if we get a sign change, then you can say it's unstable, right?
I'm not getting, just a second. Yeah, can you please repeat? Hello?
If it is not a zero row,
Yeah.
hello? If it is not a zero row, then in this method, when you substitute epsilon, we get equations in the first row, and we need to substitute limit epsilon tends to 0 normal. Thereby, we can evaluate whether it is positive or negative.
I mean, both the ways work. It's not a problem. If you are getting the value
Okay.
after substituting epsilon, then this is also correct. There is no problem with this. Okay. So all the 3 roots lie in the left half of the S plane. And what can we say? Anything more that we can say? When 3 roots are lying in the LHP, that is a very bold statement to say. But since we have got a row to be 0, that means the roots have something to do with the imaginary axis. So, since we had 0 in the first row, that means there is a pair of roots on the imaginary axis and one root is in the LHP. Okay, this is what you get from here. Okay, let's move to the next question. So this question is related to controller. Again, we are back to controllers. So consider a second order plant governed by this equation. It is desired to design a unity negative feedback closed loop control system with this plant. Which one of the following statements is true? It can be stabilized with a proportional controller, integral, or PI or PD. So do you remember we had similar question in the last class? The guys who had attended, the last question was like this only, where we found a transfer function for a differential equation and then we tried to stabilize it with the help of different controllers. At the end we came to know that yeah, just I think it was PD controller which was stabilizing. So we will be able to stabilize only with the help of PD controller because that gives us a liberty to tweak the gains for all the coefficients. In all the other cases, either the polynomial for the characteristic equation was not Hurwitz due to some missing coefficients or due to some sign change, right? So in that case, this PD controller was only making the system stable. So that was the case that was coming up there, right? So let's do here, since we had already done similar question in which we had tried with all the controllers, I'll tell you what is the correct answer here and we'll only go with that controller. So I want you to solve. What happens, I'll just tell you that the correct answer for this is option D. Now, given this is the plant, can you find out what is the transfer function? Once you find out what is the transfer function, use the controller to be Kp plus Kds. Okay. Then after this, find closed loop transfer function. Okay, which is Gs upon 1 plus GSHS.
For, e- for each option, we should, for option case, we should divide this into cases now. For example, case 1, we should solve using proportional. For case 2,
Right,
integrate controller.
right. We should solve for each of them. And this is what we did in the last class, right? Do you remember that? The last question?
Yes, ma'am.
Yeah. So definitely, because I know the answer, I'm telling you the fourth option is correct option. That is the only reason. Else what we ideally have to do, we have to go through each option. We have to change the, let it be C1, C2, C3 and C4s, the four controllers. We have to put all of them one by one, and then we have to see the characteristic equation that we are getting. Since it is just a second order system, the characteristic equation is also going to be second order only. If it is a second order system, then does it satisfy Hurwitz criteria? Are all the coefficients non-zero, or are all the coefficients of the same sign? That is it, what we need to know. If both of these conditions are satisfied by some controller, that controller would be able to stabilize the system with some change in gains. We'll have to tell what should be the range of gains of the system. But if I'll go through just first option before I move to this controller. So let's say, so what is my GS? Ys upon US after taking the Laplace? Come on, it's just Laplace transform. अरे लैप्लास ट्रांसफॉर्म तो सबने किया होगा. Why no one is answering me?
Repeat the question, Bana.
Sorry?
Repeat the question.
I'm just asking what is the Laplace transform of the differential equation given in the question. That's it.
Ma'am, 1
A
upon
square
s
y
square
of
minus
s
9.
Two of you were saying together. I did not hear any.
a square y of s
S square y
minus
of
9
s.
y of s
Okay.
minus 9 y of s is
Hmm.
equal to u of s.
Right. So from here, your GS ys upon us is 1 upon s square minus 9. Okay. Now, after this, let's say our controller transfer function is just Kp, just P controller. Then what would happen? When we try to find out the closed loop transfer function, it would be 1 upon s square minus 9. We have to do GS into CS, right? We can't skip it. So here it would become Kp. Because GS into CS, yes, GS into CS is your complete open loop transfer function. So it replaces this. This should not ideally be called GS, it should be called PS. Okay. So CS into PS is your GS upon 1 plus Kp into S square minus 9 into HS, since it is a unity feedback system. From here you can write Kp upon S square minus 9 plus Kp. Now what do you get from here? You can see the characteristic equation. It is S square plus Kp minus 9 is equal to 0. अभी s to the power 1 coefficient is missing. That means this Kp controller would not be able to stabilize the system. Similarly, you can check for the other two options, the integral controller and PI controller, both of them also would not be able to. It is very similar to the question we did in the last class. So let's check for the correct answer, which I am saying it is going to be PD controller. Let's check for it. So your PS is 1 upon S square minus 9. Your CS is Kp plus KdS, right? After this, what we'll do, we'll try to find out what is the closed loop transfer function. It will turn out to be Kp plus KdS upon S square minus 9 upon 1 plus Kp plus KdS upon S square minus 9. From here you can write Kp plus KdS upon S square minus 9 plus Kp plus KdS. From here you can write Kp plus KdS upon S square plus KdS plus Kp minus 9. Now from here at least whatever is the value of Kp and Kd, at least you can see from here that we have non-zero coefficients for all the terms, right? So this is one step into getting the system stable for a second order system. The other condition, so the question does not say it should stabilize, it just says which one of the following statements to the closed loop system can be stabilized by a PD controller. Abhi, I have already got this closed loop transfer function, but maybe my system will not be stable if the correct values of KD and KP are not there. If all of the terms, all of the coefficients are not of the same sign, my system would be stable. But stabilize कर कौन सकता है? So they can only stabilize, right? So KD has to be greater than 0 definitely, and KP minus 9 has to be greater than 0, which means KP has to be greater than 9. Okay, given these conditions, we can stabilize the system. Okay. Any confusion here? There is no confusion. We'll move to the next question. In problem 6, the same problem, the constraints on the controller parameters are what? The same question that we answered. Kp should be greater than 9 and Kd should be greater than 0, right? No confusion? Okay. Let's move forward. Okay. It is desired that a second order closed loop system, mind the words, second order, इधर आए तो कुछ तो दिमाग में होना चाहिए that there is, sorry, what? I could not hear him. Okay, let's solve this question. So this is a second order closed loop system and it should have a settling time below 4 seconds. That requires the real part of the closed loop poles to be less than what? So do you remember the discussion that I was having, that 4 minus zeta omega n में zeta omega n has some role to play? That is what we are seeing here. That zeta omega n has some role to play. Okay. So okay, let's solve this. So let's consider 2% criteria. Okay. Then our TS is 4 upon zeta omega n in plus minus 2% band. So, and from the question it is being demanded that TS should be less than 4. That means 4 upon zeta omega n should be less than 4. That means zeta omega n should be greater than 1. That means minus zeta omega n should be less than minus 1. Right? So your question was, the real part of the closed loop pole should be less than what? What were the poles? It was minus zeta omega n plus minus j under root zeta square minus j omega n under root zeta square minus 1, right? So this was the real part. It should be less than minus 1. So you see, we did not go into finding individually zeta and omega n. So settling time has a direct relation with the real part of the pole of the system. Okay. I hope this is clear. If it is, then we'll move to the next question. It is desired that a closed loop system should have a maximum peak overshoot below 18%. This requires that the damping ratio of the system be at least what? Who remembers the formula for maximum peak overshoot? What is the formula for maximum peak overshoot?
MP is equal to
What?
MP is equal to e raised to power minus zeta pi upon under root of 1 minus zeta square into 100.
Correct. Very good. Yes. So this thing should be less than 0.18. Right? From here, please find the value of zeta and tell me what is the correct answer. There are different approaches that you can take. One of them is you take log on both the sides and then solve the by squaring and all. The other is you divide into logs of multiple, but that would be a difficult approach. No, I would not suggest that. It is just that you take the logs on both the sides and then you try to find out what is the value of zeta. You would get a kind of quadratic equation at the end. Anyone got the answer for this? No one. I'll write few steps for this, but if you get the answer in between, please tell me. Okay. So from here, if you remove the log and minus sign, you'll get it to be equal to, remember, removing the log as well as the minus sign, which would invert the greater than equal to sign, greater than sign, would be 1.71. Are you getting this? 0.48. Yes, that's the correct answer. Very good. So since we've got the answer, but I'll write a few steps. So after this, what you can do, you can just square on both the sides by taking 1 minus zeta square to the other side, because it is not solvable in this form, right? Zeta square is greater than 1.71 ka square into 1 minus zeta square. Now it is easy to solve. 1.71 का निकाला, एक साइड पे किया zeta square के terms को, you'll have a constant on the other side and then you find out by taking the under root. From here you'll get zeta to be equal to, zeta to be greater than minus 0.48. Okay, this is the correct answer. Clear? Let's move to the next question if there is no confusion. Consider a second order transfer function governed by the second order differential equation. It is designed to design a unity feedback, negative feedback closed loop control system with this plant using a proportional controller. The closed loop system would be stable for all what values of Kp? That is basically the question. It is given it has to be just a proportional controller and no other controller, right? and you have to stabilize with this only. So if you're supposed to stabilize with this, where are you going? Like, what should be the value of Kp? In what range you should take that the system is stable? That is what we want to find. So let's first find out what is the transfer function of the system. So your Ps would be 1 upon Ps is pi s upon us, which is 1 upon s square plus 2s minus 4, right? This is your planned transfer function. What is your Cs? Cs is Kp. What is your Hs? Hs is 1. Fine. So let's go to closed loop characteristic equation, which is given by 1 plus Gs Hs is equal to 0. From here, 1 plus Kp upon s square plus 2s minus 4 pi. Gs is Cs into Ps, right? Ps yani plant transfer function, Cs yani controller. Everything that you have in the positive part of the loop, the forward going loop, not in the feedback. Okay, so this is your Gs into Kp is greater than 4 is the answer. I think it is. Let's move forward and see. I think it is the correct answer. Okay, so your closed loop characteristic equation is given by this. Okay, Hs is 1. After this, let's clear this out. It would be s square plus 2s plus Kp minus 4 is equal to 0. Yes, this is the correct answer. Very good. So all your coefficients of s should be non-zero. Is that satisfied? Yes, that is satisfied. The second thing is, so for that we need to have Kp not equal to 4 definitely. The other option, the other condition that we need to satisfy for the second order system is all of the coefficients should be positive. That means Kp should be greater than 4. So your first option is correct. Clear? These are very simple questions. Very, very simple. Okay, let's move to the next question then. In problem 10, in the same problem, the ratio of ES to RS is what? Okay. Yes.
Having one doubt regarding how to find peak overshoot problem. I mean, previous two problems before.
Okay.
It's a general doubt. If we want to solve the problem in calculation part, how we can calculate it? Whether calculator is not allowed, but how we can calculate these steps?
For log you need calculator, right? For log you need either calculator or log table. One of them has to be with you, because without that you won't be able to like solve the exponential term, right? So for taking the log you need a calculator or you need this, a log table with you. If you are going to solve through log table, you should know how to read the log table. That is another business, but calculator is probably allowed in the exam for this course. And then you just have to take the log. After you take the log, it is a general calculation where you just have to shift the
Yes,
terms.
ma'am. On screen calculator is available there.
Yeah, right. So it's just solving it on the side. Is that clear?
Thank you, ma'am.
Okay. So in this one, just let me copy the transfer function because this will be using a lot of times. So this is our plant transfer function. The question is asking what is the ratio of ES to RS. Okay. So your ES to RS we already saw in the beginning of the lecture, right? YS upon RS को जब हम resolve करते हैं, I'll write that step once for you. YS upon RS is GS upon 1 plus GS HS, right? Everything is with respect to the, so many times we write this to be equal to 2, right? This is basically the reference input, not the control input. So YS upon RS is GS upon 1 plus GS HS. YS can be written as, it can be written as ES into GS, right? Any confusion in this? If it is, then I'll go back to the block diagram. So tell me if you have any confusion in this statement. So what I'm doing is, you are getting ES over here and you have CS over here and then you have YS coming over here, right? Here you have references RS. So from here you can write YS is equal to CS into ES. That is the rule of block diagram reduction, right? That is why I've written this here, YS replacing it by ES into GS. GS cancels out and from here we get ES upon RS to be equal to 1 upon 1 plus GS HS. Your question is asking you ratio of ES to RS only. That is our whole question. Okay. So what you can write? ES upon RS is equal to 1 upon 1 plus GS into HS. What was our controller here? It was a KP, right? KP. So GS into HS में CS into PS. I think I had lost the connection. I'll reconnect. Okay. So in this case, what was the situation? CS was KP and PS was this transfer function. HS was 1 and multiplication of PS into CS is GS. Okay. So from here we can write CS into PS, which is GS, into HS. Okay. So what would come? 1 plus KP upon PS was S square plus 2S minus 4. This is ES upon RS. Just we need to simplify this. It would be S square plus 2S minus 4, right? And here it would be S square plus 2S minus 4 plus KP. So your answer is B, right? Yeah, B is your correct answer. Any confusion here?
Ma'am, I think it is third one.
It is 3. Are you saying option C?
Yes, ma'am.
Why C? See here, when we solve this, we'll get this in the numerator, na? S square plus 2S minus 4. We are not finding out GS upon RS. Sorry, YS upon RS. We are finding out ES upon RS, which is 1 upon 1 plus GSHS and not GS upon 1 plus GSHS. That is why. I think you have calculated GS
Okay.
upon 1 plus GSHS. That is why.
Correct, ma'am. Okay,
Yeah.
thank you.
Yeah. Okay, since we have done this, this would be useful to us. I'll copy this for the next question. because in the next question there is a question for steady state error. Okay, so ES upon RS is this. The steady state tracking error when the stable closed loop system is given as unit step reference input. Okay, so what we'll do, so in this, if this is the question, so your RS becomes 1 by S, right? So your ES becomes S square plus 2S minus 4 upon S square plus 2S minus 4 plus Kp into S. Okay, what does final value theorem say? If you want to find out error, steady state error at time equals to at limit time equals to infinity, time tends to infinity, it is equal to limit S tends to 0 S. Yes, this is what we are going to apply here to find steady state error. Instead of going into time domain by taking the inverse Laplace and everything, we won't do that. Instead of doing that, we'll directly go for this. Okay, so let's find out limit S tends to, so we want to find out steady state error, which is limit S tends to 0 S. Yes, could be S square plus 2S minus 4 upon S square plus 2S minus 4 plus Kp into S. SS cancels out. What remains? Minus, and if you put the value of S to be 0 everywhere, it would be minus 4 upon minus 4 plus Kp. Answer is B, right? Yes. All clear? If you have any question, please let me know. Okay. Okay, let's move to the next question. It's for the same question. It is now desired that the closed loop poles will be complex conjugate poles in the left half of the S plane. This would be satisfied for all what value of Kp. Okay. So if I have the demand of closed loop poles to be complex conjugate poles, how would you classify the damping of the system? Underdamped, overdamped, critically damped, or no damping? How would you classify it?
I think no damping.
No, not overdamped.
No damping. No damping.
No
Undamped.
damping. No. For no damping, you have to have poles on the imaginary axis. In this case, poles are not on the imaginary axis. They are in the left half of the S-plane. So if they are in the left half of the S-plane, it's a case of underdamped system. Okay. So if you have both the poles lying at the same place on the real axis in the left half, it is critically damped. If you have two different poles but with no imaginary terms, it is overdamped. If you have poles lying only on the imaginary axis and not anywhere in the S-plane, it is undamped. If you have complex conjugate poles lying in the left half of the S-plane, it is an example of damped system.
Underdamped.
Okay. Now, from here, it is asking for the same question. Okay. So what we are basically going to do, we just we just have to check the condition for making it under damped, and from there that would serve as a condition to find out the bounds on Kp. So let's check it out. So closed loop transfer function, what we had in the last question for gs upon 1 plus gshs, it was Kp upon s square plus 2s plus Kp minus 4, right? This is the closed loop system. This is a transfer function for which we are supposed to find out what should be the value of Kp such that the closed loop poles are complex conjugate poles and they lie in the left half of the S plane. So what we'll do, comparing it with underdamped second order system, because that satisfies this condition. What we'll do, we'll say first we'll write omega n square is what? It is Kp minus 4, right? And 2 zeta omega n is what? It is 2. From here, zeta omega n is 1. Okay? Since it is an underdamped system, your zeta is 1 by omega n. Since it is underdamped system, that means zeta is going to be less than 1. We will have the other bound also. It should be between 0 and 1, definitely. But let's check this bound first. Zeta should be less than 1. That means 1 upon omega n should also be less than 1. That means omega n should be greater than 1. Right? That means under root Kp minus 4 should be greater than 1. That means Kp minus 4 should be greater than 1 after squaring. That means Kp should be greater than 5. Right? For the other case, for zeta to be greater than 0, 1 by omega n should be greater than 0. तो ये तो इधर absorb हो जाएगा. You don't get anything out of here. Right? Because this condition is itself satisfactory. So you are not going to get anything out from here, and thus from here you have Kp should be greater than 5. Do we have in the option? Yes. Is that clear? So these hints are something which you have to take from the question. For getting the bounds on Kp, you needed to check. You needed to place a condition on zeta, and that came from this hint, that where should the poles be located. Even if you don't realize just by poles in LHP, you should see that there is conjugate pole coming in. Why would this come? If this is coming in, there is some hint hidden in this, right? I hope this is clear. Let's move to the next question. The open loop transfer function corresponding to problem 10 is of what type? So, sorry. Open loop transfer function is GS, which is CS into PS. Our CS was Kp. What was PS? PS was 1 upon S square plus 2s minus 4. This is my CS into PS. So from here it is Kp upon s square plus 2s minus 4. Can we extract some power of s out of it by taking something common such that the last term does not have any power of s? Can we? We cannot, right? It would remain s to the power 0 only. If there was another s over here, then it would have been s square minus 2s. So I'll not do here, just wait. Here it is s to the power 0. That means this is type 0. Correct answer is type 0. I'll take another transfer function which is Kp upon s square minus 2s. We can take out s from here, right? Kp upon s into s minus 2. So s to the power 1 remains here. So this is type 1 system. What we are going to do with type 0, type 1 and type 2 system, that we'll see in the next lecture. But this is how type is defined. Okay? Okay. Let's move to the last question for today. The characteristic polynomial of a closed loop system s cube plus ks square plus 2s plus 4, where k is a real parameter, then the closed loop system is stable for all what? This has to be solved using Routh-Hurwitz criteria, right? It is so clear. There is no confusion. It's just that you have a coefficient to be unknown. You have to just place bounds on the coefficient so that the system is stable. So let's construct the Routh array. Excuse me. S to the power 0, 1, k, 2, 4. So for s to the power 1 it would be 2k minus 4 upon k. This would be 0. And for s to the power 0 it would be 4, right? Now, how to make the system stable? That means this complete row should have the same sign. So you see there are two terms, 1 and 4, which are already positive. That means the other terms should also be positive, right? So from here you can write, from this what we can say, k should be greater than 0. From here what we can say, 2k minus 4 upon k should be greater than 0. That means 2k minus 4 should be greater than 0. That means 2k should be greater than 4. That means k should be greater than 2. So from here you get k to be greater than 0. This is a line. This is 0. This is 2. K to be greater than 0. This is what you get here. And from the second condition, what do you get? K to be greater than 2. So this is the intersection of both the conditions, right? So the correct answer is k should be greater than 2. Any confusion? I hope all of this helps you in solving your assignments as well, because similar questions will be there as well. Would be helpful to you. Okay, then we are done with today's session. If you have any questions, you can ask me. Else can we meet on Monday?
Thank you, ma'am.
Ma'am,
Yes.
can you tell how to prepare for GATE exam?
GATE exam.
Yes,
I'll
ma'am.
tell you, just wait. So you are currently in your which year? 4th year?
Third year, ma'am.
Third year. Third year is a good time to start. and probably now you have one attempt in third year as well. They give you 2 attempts while you're doing your BTech. That started from my time, and I think that is the rule still, if I'm not sure. Uh, for
Yeah, ma'am, it's correct.
Okay, so do give attempt in your third year as well. Fill the form, and it would be held in Feb, and you have to give the exam. Be sure that you're giving. Okay, uh, register now. Apart from that, GATE is not as hard as IIT JEE. It is not. Everyone from every college has the ability to crack this exam. It's just that you have to take your engineering seriously. That is all required. What you can do is, there are so I hope your domain is electrical, same as mine, then I can tell you.
Yeah, ma'am, electrical engineering.
Okay, so there are lectures on power systems and everything from this Gate Academy, and they are really good lectures. If you start in your fourth year when your placements are happening and when everything is like there are very few subjects, everything is chaotic, it would not be good. It's better you start now. If you haven't started, if you have started, that is even better. If you have not started, and it ऐसा नहीं है कि 1 साल लगता है प्रिपेयर करने में. गेट का एग्जाम में टाइम नहीं लगता है प्रिपेयर करने में. इट्स really easy to prepare for gate exam. What you need is to have practiced a lot of questions, and you need to like have a decent speed, and the cutoff is also not really high. Cutoff falls very low. Scoring 600 in gate exam is not at all tough, and once you have 600 700, you will, if you want to go for PSU, you can go. If you want to join any IITs or NITs for further studies, that is also easy if you have a score of more than 600. So
Total mark is 1,000, ma'am.
yeah, total is 1000, and 600 is really easy to score. I mean, the toppers are above 800, but in general, everyone who is above 600 gets a decent college or PSU. So that happens. So what you have to do is you have to prepare from Gate Academy, prepare from there. Prepare for, I don't remember, 1 or 2 more channels were there from YouTube. I used to see all of them. Apart from this, enroll yourself in, okay. You should prepare for, everyone should prepare for GATE when you are in your BTech, and that would really be helpful for you. What I'm saying, yeah, you should enroll yourself in test series. Try to not take a drop year and finish everything now only before your campus placements. Once your campus placement starts, you will be completely in different zone. That happened with me when I was in my fourth year. Placement started. Yeah, gate के लिए कौन पढ़ेगा, क्यों पढ़ना है? I want to. Everyone is getting some job every day. Some interview is happening. Some this thing. Some rounds are happening or whatever, the aptitude test and everything, and that really drains you. So before that only you should start preparing, and I would suggest you give your first attempt this year. Start preparing from the online sources. You can also purchase books from all of these, but I would say that the syllabus is really limited. Since the syllabus is limited, you need to have a practice of more questions. Your engineering teachers already might have suggested you few books and what are standard. Apart from control system is very important, by the way, in electrical engineering. You have many questions from control system coming over there. Okay, and controls सब में link होता है. You see that you have power system protection and switch gear. There are also control systems come into play. Power systems and controls में आता है. So everywhere it comes, here and there, it will keep on coming. So it is very important. Okay. So see all the lectures that are available. If you want, take subscription for one channel. One of the channels, whatever you find. So 2-3 है Gate Academy के अलावा भी. I don't remember the names now since it has been 3 years, but there are 2-3 channels, and all of these teach well only. So from there, whatever you feel is the best for you, you can take a subscription for that. Be consistent in watching the lectures, understanding the things, solve problem solving. So when they solve some numerical, they don't they come to answer. You pause the video, You solve on your own, you see if you are getting the answers, and then only move forward. So that helps you in practicing a lot. Solve all the previous year questions, they are also really important. And I think it's not tough as IIT JEE. I'm telling you, it does not require 1 or 2 years of preparation. If you just sit for 1 month, very consistent, ready to grasp everything, you'll be able to do. But don't wait for that 1 month, क्योंकि it becomes very ambitious और फिर होता नहीं है. So instead of that, start preparing for today. Look at the lectures. Start prepare. एक schedule बनाओ which should have all the courses you have done till now. Which you haven't done, you'll get it. If you're in your third year, that means you have another semester in which you'll have core courses. Because you are in your first semester of your third year, all your courses might have not been completed. So whatever courses have been done, analog electronics, very important. Digital electronics, very, very important. Control systems, very important. ये सब तो, since it might have already been done with you, start preparing from here. Solve all the questions for these questions. Or I can also take some session on GATE one day, I think. Okay. हाँ, so my point is, टेस्ट सीरीज में एनरोल करो, ऑनलाइन ही होता रहेगा. Give test every week. Take subscription of one lecture. Be consistent in watching the lectures and solving the problems. Don't be dependent on your college, that when my college will complete the syllabus, then only I'll learn. Because at the end of the day, it is any college. It is some private college, it is any government college, it is IIT. No one studies from the professors. What you do is on your own only, everywhere. This is the complete scene. So you don't have to wait for your subjects to come up. See what is the weightage of all the subjects. Whatever subjects are important, start doing. What you have already read, you are already aware of what happens in control systems, right? Since you have already gone through these 5 to 6 weeks of thing, start preparing from there. Start solving the questions now only. Since you are already in the flow, you will be able to solve more easily. That helps you in preparation of your exam also. Minimum CGPA required for getting MTech in IITs and NITs. I think during my time, so I'll tell you, my story is like, I did my BTech from NIT Sikkim, and after that, after BTech, I completed my BTech in 2022, and in 2022 itself, I got enrolled in PhD. I did not do masters. Okay, so that is my whole story. So that time also they asked for GATE exam, and the criteria was same. Whatever you get for masters, the same goes for PhD. And then they had a GPA criteria. I think it was 7.5. I don't remember exactly, but I guess it was 7.5. Try to maintain above 8.5. That should be your standard CPI in BTech. 8.5. If not 8.5, at least above 8. It should be maintained. Because that is one of the criteria, and once you clear GATE, if you have a very high rank, then you'll just have an interview and you get selected. So it's not a very tedious process after that. It's just that you have to score in GATE, and scoring in GATE is not tough. It is really simple exam. Just focus on the work that you're doing. Stay away from distractions. College में बहुत distractions होते हैं, तो you don't get to study properly. So if you study properly and focus very well. So I also, so when I was in third year, that time only this thing started. Third year में भी देना, fourth year में भी देना. I did not score well in third year because I had not completed my syllabus. My college has not completed, and I was like कि जब college में होगा, whenever I have this subject coming up next semester, then only I'll study. Now why should I study before that? So that was my way of thinking, and that was bad. So it's like अभी जितना हुआ है पहले तो उसको करो. That is the most important thing. And apart from that, जैसे ही अगर next semester का भी wait कर रहे हो, तो as soon as the syllabus, so next semester would be coming up in January, right? Don't wait for that much time. If you are able to complete all of these part beforehand, start those also beforehand, because it is seeing the lectures. It's not that your mind needs to develop a lot to see those lectures any further, right? You will be able to understand them also now also. So start preparing for it from now only. Maintain a scheduled timetable. I know your college might have some 75% attendance criteria. That is what all BTech colleges do. But apart from that, you'll have to take out the time for yourself in your lunch breaks, in your any free time. Instead of going to the room, go to the library, sit there, work on it whenever you get free time. Instead of hanging out here and there, chai tapris and everywhere, don't do that. Instead of that, you sit at some place and study. Go to library. Always be have a habit of going to library. In library also you'll get many books. Our library has a lot of book on gate exam preparation. So every library has, because everywhere BTECs prepare for it. So yes, be consistent and do give tests. Tests are very important. As important it was for IIT, the same way it is important for GATE. You need to give it.
Ma'am, weightage is varying year by year. So how to find weightage of subjects?
Weightage of subjects you'll be able to find out from the previous year questions only. And it varies, but it not varies so much. Well, it can happen sometimes, but if you see, if control systems has weightage for last 50 years, but if this year you just have two questions for control system, then no one can do anything now. It depends who is setting the question and what is going in their mind. So we cannot do anything there. But there are some subjects which you can think that yeah, this is not so important. Abhi, I'll not have some, for example, I had a course on materials also. I don't remember the exact names. I don't remember, but there was not much question from that, and it was always known that there are not much questions coming up from there. So yes, whatever is there in the previous year question, we solve everything without thinking about
I
anything.
have,
Hmm.
I have physics wala channel. I have studied engineer mathematics, no, but I'm unable to solve any previous year questions. No. Similarly, I have enrolled in network analysis in NPTEL, and I have
Hmm.
written exam, and I have failed in it by 20, losing 7 marks. No. Even though I prepared for it, I'm unable to solve PYQs of GATE.
But are you able to solve the PYQs even if your NPTEL exam was not good?
No, ma'am. Each and every question has different concept. I'm still studying to solve it.
Then go through the lecture
I can
first.
understand the concepts by seeing lecture videos. I can understand it. For any subject, I can understand it. While coming to solving problems, I'm unable to solve questions.
Then that requires practice. That requires very, very much practice. If you're not able to solve at once, come back to it after 5 days. Solve it until you get it correct. There is no chance by which you get it wrong. And solve many similar questions. Nowadays, ChatGPT is also there. It is something, modern problems require modern solutions type of thing. So that also helps you. You have to tell chat gpt that I am facing problem in solving this question. It will definitely give you a correct answer. Then say that give me 5 more variants and how it can be twisted, how what all things can be done. Ask it to do it for you, because problem solving is
Okay.
really important, and it is coming from some concept only. It could be that it is a combination of 2 to 3 concepts. That could be the only thing, and if that is the case, that means all your lectures are not very clear. If you had enrolled for network analysis and synthesis course, and then you're facing this problem, that means the source from which you studied was not working 100% for you. It might have worked for many other people, but that was not the one which you needed. So go for other courses. Look on the internet what all courses are available for the same course and how they are teaching. See if that benefits you. Because see, if and the courses should be such that when they are teaching you, they are also solving some of the problems. एक concept बनाया बताया, then they have 2 to 3 questions coming up. So that helps you. So instead of just learning the theory and leaving numerical for later, that okay, when this comes then only I'll solve, it won't help. Instead, look for a source where they are teaching the theory, then taking 5 questions, then teaching a theory, then taking 5 questions. You'll be able to solve.
Okay. Thank you.
Yes, prepare well, give exam this year, you'll get much idea that how the things are going. And in controls, the questions are really easy. Whatever you are solving in your assignments now, it is of that type only. It can get sometimes difficult, but it would be like, abhi, just if in one of the questions it was कि complex conjugate poles, where you have to take some hint out of the question. That kind of questions are there, and for that you need to know the concept. So when Professor Shankar Ram says that this gives you a hint in the lecture, note it down and remember it. Don't forget. Okay?
Okay, ma'am. Thank you, ma'am.
Okay then. See you next Monday. Bye.
Bye, ma'am.